Hi, and welcome to another series of Fitz Talks. This is your ultimate teach guy, Sir Fitz. For this day, we will be talking about another information, another discussion in physical science for grade 11. For this time, we will be discussing about chemical reaction. So be ready, stay tuned, and prepare your materials to learn. And of course, prepare yourself and enjoy this video lesson. For this lesson, here are our objectives. Objective number one, using simple collision theory to explain the effects of concentration, temperature, and particle size on the rate of reaction. Objective number two is to define what is the meaning of catalyst. And finally, the objective number three is to determine the limiting reactant in a reaction and calculate the amount of product formed. Before we start our new discussion, let's have a review of our previous discussion. Last time, we have talked about regarding with biological macromolecules or biomolecules. So what is the meaning of biomolecules once again? Last time, we have discussed regarding with biological macromolecules. Based to our discussion, biological macromolecules is also known as biomolecules. These molecules are important cellular molecule that performs a various range of life processes and its sustenance. Also, in addition, the following are the biomolecules. We have nucleic acid, carbohydrate, lipid, and protein. These particular biomolecules are composed of the following monomers. For nucleic acid, we have nucleotides. Carbohydrates is composed of monosaccharide. For lipid, that is a combination of fatty acids and glycerol. For protein, we have the amino acids. Each of the biomolecules are very important in the sustenance of life and, of course, in performing life itself. For this new video lesson, you will encounter the following terminologies. You can take note of this terminology and throughout of our discussion, you will identify or you will discover the meaning of this terminology. We have effective collision, temperatures, collision theory, endothermic reaction, catalyst, concentrations, balancing of equation, exothermic reaction, and transition state. I know that you are now ready for our video lesson. So let's dive in. The first guide question for our video lesson is, what is collision theory of reaction rates? Before we answer the first guide question, let's have this particular information. What is the meaning of chemical equation? Since this particular topic will be regarding with chemical equation and chemical reaction. When we say chemical equation, this is the symbolic representation of the chemical reaction wherein all the chemical elements or substances involved are being represented. If we will give an example of chemical equation, it will look like this one. As you can see on our presentation, we have the following parts. You have the reactant or the substrates, of course, the product, and in the product and the substrates, you have the chemical formulas. Each reactant and product has a particular coefficient. But what is the meaning of each parts of this particular chemical equation? The first part is the reactant. Reactant is the substance that undergoes change during reaction, while product is the substance formed as the result of the chemical reaction. While coefficient is the number placed in front of a chemical symbol or formula. I hope that this particular review will give you an information and you will use this information throughout of our discussion. Now, let's have the first guide question, and that is about the collision theory of reaction states. This particular theory states that for reactions to occur, molecules, atoms, or ions must first collide. It means that all of the atoms or molecules involved in a chemical reaction should have collision from the term itself. During this collision, reaction will happen or occur. As you can see to the interpretation or to the illustration, you can see here that we have a reactant particle approaching to each other. We have the reactant A and of course the reactant B. This particular reactant will undergo collision, whether it is effective or ineffective. For effective collision, as you can see, it has a successful collision between the two substrate or two reactant. And then finally, it will form a product. And of course, for the ineffective collision, it showcases unsuccessful collision, wherein two substrate or two reactant doesn't totally have any collision to each other. That's why the reactant particles move apart without reaction. Remember that for you to have an effective collision, you should take note of these two factors. The first factor, it should be or it should have a minimum amount of energy. And number two, it should have a proper orientation. Once again, for you to have an effective collision, you should take note of the two factor. The first factor is the minimum amount of energy, and of course, the second factor is the alignment of the particular element or particles. As you can see to our illustration, we have the two, the proper alignment and of course the improper alignment. As you can see, for proper alignment, the two reactants are properly aligned or correctly aligned. Therefore, they will have an effective collision and they will produce a particular successful product. While for improper alignment, the collision will not happen because their alignment or structure are not properly arranged. This will lead to unsuccessful collision reaction. Take note of this one. Remember that during the process of chemical reaction, it requires bond breaking or forming. Once again, it requires bond breaking or forming. This is accompanied by changes in the potential energy or PE. As you can see to the illustration showcases to you, the blue bar column represents the heat and the light energy, while the green bar represent the potential energy. When atoms are bonded to each other, the potential energy and the kinetic energy or the heat and light energy are somewhat equal to each other. While when there is a broken bond, potential energy increases and new bond forms, potential energy decreases. Now, let's have the second guide question. After knowing what is the meaning of collision theory, why it is important to know? Remember that chemical reactions are needed to pass through high energy, short lived intermediate state, also known as the transition state. On this particular state, the kinetic energy or Ke of the particles must overcome the Pe or the potential energy. This is essential for breaking and creating bonding. On this illustration, it showcases when transition state occurs. Of course, every reaction will start from this to one. This initial state, when in the reactant, will be activated through the increase of kinetic energy. And then, of course, transition state will reach when the kinetic energy increases. At the same time, the potential energy will also increases. And then afterwards, this transition state will decrease now going to the final product or to the result of the reaction. This scenario is what we call as the transition state theory. Once again, if you will observe to the illustration, the reactant will be activated through the use of kinetic energy to overcome the potential energy. When the proper stage met, transition state will occur. And then finally, from transition state, it will now have a result or the product. It is clear to us now that during the chemical reaction, we still have two main processes involved, and that is breaking of bonds and, of course, forming of bonds. During these two processes, energy has been absorbed or released. When there is a breaking of bonds, energy is being absorbed, and while there is a forming of bonds, energy is being released. I have here two diagrams that will showcase to you the two energy that we have discussed. The energy absorption and of course the energy releasing. If you will observe properly and carefully, the two diagram looks like a mirror image. Mirror image that this particular diagram on this one, as you can see, the line goes up and then of course going down, but not totally on the lowest level. While on this one, it will begin on this level, then going up and then going down to the lowest level. So if we will discuss it or if we will relate it to the collision theory, it will begin to an average energy of reactant. Of course, every reaction will start from a reactant. On this diagram, the reactant energy starts at the lowest level. And of course, it will need activation of energy or additional kinetic energy to reach the transition state. When the transition state reach that level of energy, it will now go down to its minimum amount of energy. But it will not totally go down because nagkaroon nga ng energy absorption. While to the other diagram, it started from a high energy that eventually this reactant has a constant reaction and then activation of energy will happen or additional of kinetic energy. From this transition state, it will greatly go to the lowest level of energy. Therefore, there is an energy releasing. If we will identify these two diagrams, it will be the following. This diagram, as you can see, will be the endothermic reaction, while the other diagram is the exothermic reaction. Now, the question is, what is the meaning of endothermic and exothermic reaction? We are now on the third guide question. What is the meaning of endothermic and exothermic reaction? Endothermic and exothermic reaction are the two reaction involved in a chemical reaction or chemical equation. So you can see endothermic reaction is the energy absorbed more than the energy released. It means that the energy is being absorbed from the reaction of reactant and of course going to the product. While exothermic is the opposite of endothermic. Exothermic energy absorbed is less than to the energy released. That's why exothermic releases the energy throughout the process of chemical reaction. Another thing is that endothermic has higher energy of the product but lower energy of the reactant, as based to the illustration showed to you lately. While exothermic has a lower energy of product but higher energy of reactant. That's why on endothermic, it has a positive heat reaction, while for exothermic, there is a negative heat of reaction. So what will be the impact of this particular two reaction? When there is an endothermic reaction, The reaction feel cool to the touch. Ibig sabihin, yung reaction na involved doon kapag hinawakan mo yung kanyang product, malamig yung naging product or yung naging result ng reaction. Well, for exothermic, it is opposite of the endothermic. Reactions feel warm to the touch. When you touch it, after the reaction, the product is somewhat hot or warm. So what are the factors affecting the reaction rates of chemical? Basically, we have four factors affecting chemical reaction. The first one is concentration, temperature, surface area, and of course, catalyst. Let's discuss this one by one. The first factor affecting chemical reaction is the concentration of reactants. It is the amount of reactant applied to the reaction. Remember that when there is an increase in reactant concentration, ensures that there will be more collision between particles. Therefore, it will result for faster reaction. If I will show to you a diagram or interpretation for that one, it will look like this one. So you can see this one has a lower concentration of reactants. Here we have few molecules, therefore there will be few collisions and the rate of reaction is slow. But when we increase the concentration of the reactant, we will now have more collision, therefore the rate of reaction is greater or faster. The second factor affecting chemical reaction is temperature. Temperature is the measurement of hotness or coldness. For collision theory, when there is an increase in temperature, there will be also an increase in kinetic energy, therefore increasing the number of collisions and faster reaction. If I will have an illustration for this one, it will be look like this one. So as you can see to the illustration, we have here the kinetic energy and of course the kinetic energy of the particle. For this one is the probability of a particle with that kinetic energy. When there is lower temperature, the product will have a lower kinetic energy as you can see to the illustration or to the line graph. While if there is higher temperature, the proportion of particles will have a sufficient amount of energy to react or to collide with each other. The third factor affecting the chemical reaction is surface area or particle size. This is the amount of space covering of an object. If we will relate this one to the collision theory, an increase in surface area relates to more particles being available for collision. Therefore, faster rate of reaction is expected. So I have here a diagram showing to you the difference between a low surface area and high surface area. For this to one, we have bigger size solid reactant, therefore particle in gas, liquid, or solution of the other reactant. Smaller or total surface area of solid reactant will have a lower frequency of collision at its surface. Therefore, it will have a slow reaction. While if the solid reactant break into smaller pieces, giving a larger surface area, it will have a higher frequency of collision at its surface, therefore having a faster reaction. The fourth factor affecting chemical reaction is what we call catalyst. Catalysts are substances added to chemical reaction to increase its reaction itself. Therefore, it will speed up the process. At the same time, it will also speed up the reaction. Since there is an increase of reaction due to the speeding up of the process, therefore, it will have a faster reaction. Now let's play this game, faster or slower. For this game, you need to identify what will be the chemical reaction rate of the following substances. You need to identify whether it is faster or slower by means of its chemical reaction. Are you ready? That's great. Let's move on. For this game, you need to identify the rate of chemical reaction of each substances. You need to type in or to encode or to write it on your lecture notebook whether it is slower in reaction or faster in reaction. As you can see to your screen, we have four tables. This table represent the criteria of our game. You have the normal condition, change condition, and the factor affecting the chemical reaction, and of course, the rate of reaction. You can pause for a while you are answering the particular substances. And then when you are done, you can proceed to the next substance and so forth. So are you ready? Very good. So let's start with the first item. For our first item, you have 20 gram of salt that eventually becomes a 15-gram salt. So this particular substances is an example of factor in the concentration. What do you think will be the rate of reaction for this particular substance? Is it slower or faster? Answer it now. Let's reveal the answer. For this one, the answer will be slower. Once again, for concentration, when there is an increase in concentration, therefore, there is a more possibility of collision. Therefore, it will have a faster reaction. For this example, as you can see, there is a lower concentration from the change condition. Therefore, the answer will be slower in reaction. Now, let's move to the second item. Second item, we have 100 degrees Celsius of water and 200 degrees Celsius of water. This particular example is under the factor of temperature. What do you think is the reaction for this particular substance? Write your answer now. The answer for this example is, of course, faster because there is an increase of temperature. When there is an increase of temperature, therefore, there is also an increase of the chemical reaction rate. Last example, or the third example for this one, we have powdered table salt and normal table salt. This example is under the factor of surface area. What do you think is the rate of chemical reaction for this example? Okay, time's up. The answer for this one is slower because as you can see to our example, from powder table salt, which is higher in concentration, goes to a lower surface area. Lower surface area will have a lower possibility of collision. Therefore, there will be also a lower chance of reaction or slower reaction. I think you are now ready to answer our different exercise after this video lesson. Remember the discussion and remember the information that you have gathered from this topic. Let's move on. One good application of our discussion is about the food industry or the manufacturing of our food itself. Catalyst is being applied in the production of food to speed up the process, therefore creating more food for the people. So, how this particular process is being occurred? and of course, how this particular process are helpful for our society. Remember that enzyme is also a catalyst, but enzyme are the biomolecules essential for speeding up the chemical reaction rate in our body or in our cells. One of those significant example are the following. So we have the example under dairy production, brewing, baking, wine and fruit juice, and of course in meat. We have the example, we have the enzymes lactase, protease, catalysis, glucanase, amylase, protease, amylase again, and of course the other example. For this one, for dairy production, we use the enzyme to process milk production. And of course, for creating drinks or alcoholic drinks, and of course, for the decomposition of bread, fermentation, and of course, for the decomposition or the degradation of this particular structure. So enzyme is very important for food industry. Without them, our food will not become more accessible to the different types of people and different types of society in all over the world. Also remember that all chemical reactions should be stable. Therefore, we will now go to the next topic, which is chemical balancing. Take note that the main principle of chemical balancing is this particular statement. What you see in the reactant should be present also in the product, or reactants and products should be balanced to each other. It means that whatever you will see in the reactant should also be present in the product, or it should be balanced to each other for them to become stable. So I will give some example of those chemical equation that are balanced already. So we have this chemical reaction or chemical equation. We have carbon oxide plus the oxide, and the product is carbon dioxide. For us to know whether the equation is balanced is to count the elements or the atom present to the reactant and to the product. As you can see for this one, we have one carbon, one oxygen, and of course, the two and the third oxygen. While for product, we only have one carbon and of course, two oxygen. As you can see already, there is an imbalance of number of atoms. Therefore, this one is not balanced. Specifically, oxygen is not balanced to the reactant and to the product. Now, let's balance this particular equation. How? How we will balance this equation? So once again, I have here the equation. You have carbon oxide plus oxide, and the product is carbon dioxide. First thing first, you need to count again the number of atoms present to reactant and to the product. After counting the number of atoms to the reactant and to the product, try to balance it by putting coefficients to the particular elements. Let's proceed. So I will put the coefficient of 2 to carbon oxide and of course 2 to the carbon dioxide in the product. Afterwards, I will perform now the distribution process in mathematics. We have 2 times 1 for carbon, so therefore you only have 2 carbons now. And moving forward, 2 times 1 to the oxygen, you have 2 oxygen for this one. Then, of course, we have the third oxygen into the fourth oxygen of this particular reactant because we already have 2 oxygen here. For product, we will just repeat the process. Distribution method in mathematics, you have 2 times 1 because only one carbon is present. Therefore, that is 2. And of course, 2 times 2, which is present in oxygen, that is equals to 4. So we have now 2 carbon for product and 4 oxygen for product. Now, let's summarize this particular answer. We have again the carbon, which has 2 atoms, and oxygen also has a 4 atom for the reactant. Well, for the product, you also have 2 carbon and of course 4 oxygen. Therefore, we can say that this particular equation now is what we call balance. Now, let's try this particular game, Balance Me. Take note or solve this particular equation to your lecture notebook. For this example or for this game, I will be showing to you this equation and try to balance this equation. Once again, you can pause this video while you are solving the balancing of the equation for this example. So I will reveal now the equation. So for this example or for this game, we have methane plus oxide. And the product is carbon dioxide and water. Try to balance this equation. You can pause for a while you are answering this particular game. So I think you are now ready for the reveal of answer. Let's balance this equation once again. Once again, our steps are the following. Step number 1 is to count the number of atoms present to the reactant and to the product. We have the following elements. We have carbon, hydrogen, and of course oxygen. And now, let's count the atom to the reactant and to the product. For the reactant, we have 1 carbon, 4 hydrogen, and 2 oxygen. For the product, we have 1 carbon, 2 hydrogen, and 3 oxygen. As you can see, by means of counting the number of atoms, there is already an imbalance of elements or number of atoms. What we need to do now is the second step or step number 2. Step number 2 is we need to put in now the coefficient that will balance or that will add up the chemical reaction for it to become stable. So I will have now the following coefficients. So I added the coefficient 2 and 4 for the reactant. Also for the product, I have 2 and then 4. Now, I will distribute this particular coefficient through the use of mathematical operation. Let's begin first for CH4. I have the coefficient 2 distributed to carbon and of course to hydrogen. If I will distribute 2 to carbon and hydrogen, 2 times 1 will be 2, as you can see to this one. Then I will continue to distribute 2 to other elements. We have 2 times 4 is equals to 8. And now for oxygen, I have put in 4 as coefficient. Therefore, 4 times 2 equals to 8. So I have now the following or the new number of atoms. For carbon, I have 2. For hydrogen, I have 8. And for oxygen, I have 8. Now, let's move to the product. For product, let's distribute 2 to carbon dioxide. So 2 times carbon, which is 1, this will be equivalent to 2. And then 2 times 2 because oxygen has 2 atoms, therefore it will have, sorry, let's move to hydrogen muna. So for hydrogen, we have H2O. So therefore, 4 times 2 because we have 2 hydrogen atom. So 4 times 2 is equals to 8. And now, let's move to oxygen, yung kanina. So first one, I have 4 because 2 times 2 to the number of atom of oxygen, I have 4. Then for this side, I have 4 times 1 because there is no subscript for this oxygen. So I have 4. So 4 plus 4 is equals to 8. Now let's check if this is already balanced. Carbon has 2 in reactant and 2 in product. So this is balanced. Check. For hydrogen, I have 8 and 8 to other side. So this is check. For oxygen, I have 8 and of course another 8 for this side. So that is how you balance chemical equation. Take note of this process because you need to have these skills throughout of this video lesson. And of course, for the quiz. So that is our discussion for weeks 5 and 6. I hope that you have learned so much for this discussion. You can review again this video lesson, take note or take a screenshot of the important details from this video lesson, and proceed now to answering the different activities in our FLMS or to our learning management system. Thank you so much for listening and see you next week for the new video lesson.